Welcome. This part of the video for 7.3 is going to look specifically at this idea of polyatomic ions. We've been looking so far at monoatomic ions where there's one kind of atom, one element that gains electrons or loses electrons. So they're called monoatomic, meaning a one atom ion. But it's also possible for a group of atoms to gain or lose electrons as a group. And in fact, this group of atoms bonds together covalently, which we'll learn about in Chapter 8. And so together they act as an ion, but there's several atoms, so now it's called a polyatomic ion. A couple things to know about polyatomic ions. Usually they form anions, negative ions. It still acts like a single ion with just one oxidation number, so you treat the whole thing just as one group. And many contain oxygen and are also called oxyanions. So if a compound needs more than one of a polyatomic ion to balance the electrons lost and gained, you use parentheses around the entire polyatomic ion and then use a subscript to show there's more than one. You never change the subscripts inside the polyatomic ion or drop those subscripts. So let's look at an example. Sodium combines with sulfur. Well, if I look up sodium, it's Na in family 1A, so it's got one electron it would like to get rid of. Now sulfate I can find, kind of sounds like sulfur, but not quite the same. If sulfur were in the compound, it might be called sulfide, but not sulfate. So on the back of your periodic table, there's a common ion chart, and you could Google this and find them anywhere. You could take a picture and put it in your gallery or on your desktop. But SO4 is one group representing sulfate, and it needs 2 electrons to be stable. So when I draw this, I see one sodium is not enough to get a sulfate stable. So I'm going to need a second sodium to finish the job. So this formula would simply be Na2SO4. Okay, SO4 is exactly what I saw for sulfate on the chart. I didn't change the formula. I don't need more than one, so I can just write it like this. If I had magnesium with chlorate, now when I look at magnesium, it has 2 electrons to give. Chlorate, when I find it on the chart, there's a lot of them. There's chlorite, chlorate, and perchlorate, so make sure you find chlorate. It is ClO3, and it's shown with a minus charge. And remember, chemists are lazy, so that just means -1. So this whole group, ClO3, can only take 1 electron. So that's not going to be enough to get magnesium stable. I'm going to need to bring in a second chlorate to take that second electron. So now when I write this, I have to write Mg, then I write the Cl3, and now to show there's 2 of this whole thing, 2 chlorine, 6 oxygen total, I use the parentheses and a subscript of 2. So see if you can write the correct formula for the following. Go ahead and pause here and see what you could do on your own. So sodium has 1 electron to give. Hydrogen carbonate, I find it and says it's HCO3. It can take 1 electron. So this is just going to be a 1-to-1 ratio, or NaHCO3, sodium hydrogen carbonate. Magnesium and chlorine, Mg has 2 to give. Chlorine, if you're looking for it on your common ion chart, you realize it's not there because chlorine is just Cl with a minus. And I will need 2 of those, so this is going to be MgCl2. Here's a couple more for you to try. So I'd pause it and try again. Magnesium, I find, has 2 electrons to give. Hydroxide is an OH group, which can take 1 electron. So I will need 2 of those. And here's a common mistake. People like to write MgOH and just put the 2 there. But remember, it's 2 oxygen and 2 hydrogen, 2 of this whole group. So I still need the parentheses. Ammonium nitrate. Ammonium, if you look for it on the periodic table, you won't find it because it's actually NH4. It's a polyatomic ion. The only positive one on our chart, the rest are all anions. And the nitrate, NO3, -1. So this will just become NH4, NO3. Here's my last couple for you to try, so pause one more time and see what you come up with. Hydrogen has 1 electron to donate. Peroxide is actually a little different than oxygen. If you find it, it's an O2 group with a -2 charge on it. So it needs 2 electrons to get stable, meaning I will need 2 hydrogen to make this work, and this becomes H2O2, a little different than water. Calcium phosphate, calcium has 2 electrons to donate. PO4 needs 3 to get stable. So this is one of those ugly ones. I may need to do a little work, but you'll get so you recognize these more quickly. I can quickly see I'm going to need another calcium, which takes care of that one, but now I need another PO4. And those of you who are, more comfortable with math will see the math relationships pretty quickly on these. Kind of brings back your least common multiple stuff you've done. So this will be Ca3, and then I need 2 of the PO4, so I need the parentheses and the subscript of 2. So how do we name ionic compounds? Well, the cation is always listed first and the anion second, so that's how we name them. We use the element's name for the cation, and for the anion we make just a small change. For a monoatomic ion, we change the last syllable of the anion to an IDE ending. Like chlorine becomes chloride or oxygen becomes oxide. If it's a polyatomic ion, we use the name of the ion, just like it's given on the chart. Peroxide, sulfate, whatever. For a transition metal, you also need to include the Roman numeral numbers after the metal's name to tell what the oxidation number was, whether it was copper 1 or iron 3, etc. Except silver, which is always a positive 1. So try naming the following, and go ahead and pause and see what you come up with for names, and I'm going to go ahead and write in my solutions now. So the first one would be potassium for my anion, and since it's not a transition metal, I don't need to worry about a Roman numeral, and then iodine would simply become iodide. Second one is calcium for my anion. And then ClO4 is some kind of polyatomic ion, and when I look it up, I see it's perchlorate. So I just keep the name exactly as it appears on my chart. And again, calcium is not a transition metal. Silver is a transition metal, but since it's always a +1 oxidation number, I don't need to include the Roman numeral. And then nitrate is the polyatomic ion. And then finally, copper is combined with chromate, CrO4, if you look, it's chromate, not dichromate. And now here's the tricky part. I have to figure out what my Roman numeral should be. And the way I do it is I look at chromate and see it has a -2 charge. And I only have 1 chromate with 1 copper. So if CrO4 needs 2 electrons and 1 copper can take care of that, that lets me know this must be copper 2 in order for this to work out. Here's a couple more for you to try. So again, I'd encourage you to pause it before you listen to my solutions. So the first one is going to become sodium sulfate. Nothing tricky. Second one, magnesium. And again, there's a lot of similar chlorate groups, but this one is just chlorate, so magnesium chlorate. And then I have sodium with just sulfur, so this becomes sulfide. And then I have iron with oxygen, so it's going to be iron oxide. But again, it's a transition metal, so I need to figure out that number. Oxygen needs 2 electrons. I only have 1 iron combining with it, so I know this must be iron 2 oxide.